Hydrocarbons are organic compounds that contain hydrogen and carbon. There are three kinds of hydrocarbons: alkanes, alkenes, and alkynes. Alkanes contain only carbon-carbon single bonds. Alkenes contain at least one carbon-carbon double bond. And alkynes contain at least one carbon-carbon triple bond. And just remember that each carbon will have a maximum of 4 bonds. So we usually just fill up the empty bonds with hydrogens. So now each carbon has a total of 4 bonds. When naming hydrocarbons, the ending of the name tells you what kind of hydrocarbon it is. So the ending of an alkane is ane. The ending of an alkene is ene. And the ending of an alkyne is ine. So the examples that I drew, the first one is ethane, the second one's ethene, and the third one's ethyne. Of course, naming hydrocarbons is going to get a little more complicated once the chains get bigger. So we're going to start out by just naming alkanes. That's the simplest type of hydrocarbon. The International Union of Pure and Applied Chemistry has rules for naming hydrocarbons and all other organic compounds. Simplified, the names all contain a root and a suffix. The root tells you how many carbon atoms exist in a single molecule of the compound. And the suffix tells you the type of hydrocarbon. So whether or not it's an alkane, an alkene, or an alkyne. So the number of carbon atoms is signified by the root in the name. So I have a list of 1 to 10 carbon atoms. I'll go through what the root is and then what the corresponding alkane would be called. If there is only 1 carbon atom in the molecule, the root of the name is meth. And the name of the corresponding alkane would be methane. Meth for 1 carbon, ane because it's an alkane. To draw the structural formula of this molecule of methane, you would have 1 carbon. And remember, each carbon atom must have a total of 4 covalent bonds. So there are my 4 bonds, and I fill it in with hydrogens. So there's a molecule of methane, and its corresponding formula would be CH4. 2 carbon atoms has a root of eth, so the alkane would be called ethane. So eth, there's 2 carbon atoms. Ane, there you have a single bond. Each carbon atom has a total of 4 covalent bonds. And I fill in the empty spots with hydrogens. There's 2 carbons and 6 hydrogens, so the formula for ethane is C2H6. 3 carbon atoms has a root of prop, so the alkane would be propane. 3 carbons bonded together, and the 4 bonds are filled in with hydrogens. So what I drew just now is called a structural formula, and as you can see, it's going to get tedious drawing all those hydrogen bonds every time that I'm drawing a bigger and bigger molecule. So there's something called a condensed structural formula, and it would look like this. So it makes drawing a little bit easier because you don't have to draw in all of the hydrogens bonded to each carbon. You just have to draw in how many there are. There's also something called a line structure, and for propane it would look like this. So each point in your structure represents a carbon atom, and it's just implied that the empty spaces are filled up with hydrogens. So any way you draw it, you'll get the same formula. C3H8, 3 carbon atoms and 8 hydrogen atoms in 1 molecule of propane. I'm not going to draw the rest of the structural formulas. I'm just going to show you the roots and the names of the alkanes. So if you have 4 carbon atoms, the root is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, 10 is dec. Just like when you're naming regular polygons in math. So just remember, for naming alkanes, you start with the root, which tells you how many carbon atoms there are in a molecule, and then you end with the suffix ane to indicate that there are only single bonds. So 4 carbons would be butane, 5 would be pentane, 6 is hexane, 7 is heptane, 8 is octane, 9 is nonane, and 10 is decane. And you should be able to draw a structural formula, a condensed structural formula, and a line structure, just like I did for propane. So the naming that I just went through works really well when you're dealing with straight chain alkanes. What I mean by that is if you have a molecule where all the carbon atoms are connected in sequence in a single line, something like that. The naming gets a little trickier when we talk about branched chain alkanes. So what I mean by that is, well, you could have a long chain of carbon atoms in a straight line, but you could have a branch off like that or down here. How do you name those? That's a subject for another time.